Alright guys, today we're still proving triangles congruent. Man, we've been doing that for a long time, and you probably noticed so far that in all the proofs we've done, we haven't had any hypotenuse leg proofs yet. So you can tell that we haven't done that for a reason, because there's a lot of work to do when you do a hypotenuse leg proof. So that's what today is. We got 4 snazzy hypotenuse leg proofs. So let's take all this given, segment AD congruent to segment CB. Let's write it down and mark it. And segment AB is perpendicular to segment AD, so that goes meow. And segment BC is perpendicular to segment DC, so we'll write that down with a given. But hypotenuse leg takes a lot of work, guys, to get it done in front of the math judge, where you got to prove it. Like, to do hypotenuse leg, you have to have right triangles in your proof first. Of course, you kind of see it in the picture, but it has to be written in the proof that we have right triangles. And before we can get right triangles, we have to have right angles in there, and that has to be written in the proof. And before you get a right angle, you have to have something that measures 90 degrees. So you need an angle that measures 90 degrees. Well, here's how we got to roll, man. When they give me things are perpendicular, the definition of perpendicular says that those things intersect at a 90-degree angle. So what we can say is that the measure of angle A equals 90 degrees, and then we'll put a semicolon because we also have another angle. The measure of angle C also equals 90 degrees. And why did I know that? Because they gave me perpendicular, and that's what perpendicular means. So that's the definition of perpendicular. If things are perpendicular, they intersect at a 90-degree angle. Okay, so we need that. The next thing we need is we need some right angles in our picture. Well, if angles measure 90 degrees, that means they're a right angle. So we can say that angle A and angle C are right angles. And we can abbreviate right, RT, if you want to. And the reason why they're right angles is because they measure 90 degrees. Like, that's what it means to be that. So that's the definition of a right angle in that case. So that helps us. We needed right angles, so that way we could have right triangles. A triangle can't be a right triangle unless it has a right angle in it. Here's some right angles. So step 4, we can say that triangle ABD and triangle CDB are right triangles. And the reason is because they have a right angle in it, and that's the definition of a right triangle. And usually, if we let students do this on their own, they wouldn't put any of this stuff in their proof. There's 6 steps that they would be missing. So I know I want to do hypotenuse leg in this situation. So I needed a right triangle. To have a right triangle, you have to have right angles. Before you can have right angles, you need angles that measure 90 degrees. And before you know they measure 90 degrees, they had to give you some perpendiculars. So I'm kind of golden now to do hypotenuse leg, except that I don't have a tick mark on the hypotenuse yet, so I have to use the shared side. So I'm going to go ahead and do that as step 5. That segment DB is congruent to segment DB by, that's the reflexive property. We're getting really good at that, of congruence. Don't forget that little nugget. And now we've got tick marks on the hypotenuse, we've got a tick mark on the leg, and we have right triangles. So we can finally say that triangle ABD is congruent to triangle CDB by hypotenuse leg congruence theorem. So if you're ever going to do hypotenuse leg for a proof written down, we have to have lots of stuff. But we might not need it all. We don't need this whole box of 3 steps here every time. We have to think in reverse order. I need a right triangle. If they give me that, that's awesome. But if I don't have that given, I have to get it in there somehow. Before you can have a right triangle, you have to have a right angle. And before you have to have a right angle, you need 90 degrees by perpendicular. So think backwards. So let's try another one. That's going to be hypotenuse leg. It's just kind of all we're doing today. So I'll let you pause the video so you can write all this given down. And then we'll go mark it. So segment XY, bada boom, is congruent to segment ZW, and the measure of angle Z is 90 degrees, and the measure of angle Y is 90 degrees. So what we should probably kind of do first is like maybe that shared side. On the previous problem, I didn't do the shared side first. Let's do the shared side first so we can see, oh yeah, dude, I totally am going to do hypotenuse leg on this guy. So it doesn't matter if you do it first or last or whatever, but it has to be in there somewhere. So segment XW is congruent to itself by the reflexive property of congruence. And then when you do that, you have your vision here that's like, okay, hypotenuse leg is what I need, but guys, we got to think backwards. I need right triangles written down in my proof. I don't have that anywhere written down. How do I get right triangles? Right angles. I don't have that written down. How do I get right angles? I need 90 degrees. Ooh, I do have that written. As opposed to back here before, they gave me perpendicular and I needed to write that. They gave me the 90 degrees, so I can go straight to the step after the 90 degrees, which is saying that angle Z and angle Y are right angles. And the reason is because that's the definition of a right angle. It's supposed to measure 90 degrees, and I know that because they told me so. I didn't have to like have that step written in my proof. I didn't use a definition of perpendicular because they didn't give me perpendicular. They gave me 90 degrees. So I got my right angles, and now that allows me to say that I have right triangles. Any triangle that's got a right angle in it is a right triangle. So they told me the names of the two triangles. I'm going to just use that. I'm going to steal it. Oops, I didn't want to say they're congruent. Sorry, I'm not thinking what I'm writing down. I'm going to say that triangle XYW and triangle XZW are right triangles by the definition of a right triangle. So cool. I need right triangles to do hypotenuse leg. I now have it. I also got my reflexive property in there with that shared side, so I can go ahead and do step 5 now that says that the triangles are congruent by hypotenuse leg. I keep writing the same thing down. Sorry guys, I'm having a silly time here. XZX, that should be a W. That's why I wrote that down before. XZW. There's a typo right there. Sorry about that, guys. Whoever made this worksheet should be shame on them. Oh yeah, that was me. Hypotenuse leg congruence theorem. So, alright, to recap, this one only had 5 steps in it compared to the last one that had 6 steps in it because they didn't give me the 90 degrees on the first problem, they gave me perpendicular, so I had to use its definition. Here I could sneak away from that because I went straight from the 90 because they gave it to me. So let's try another one of those dudes. It says all of this cool given stuff, so I'll let you pause that video, write her down. Now I'm going to mark it. Segment PS, that's this whole dude. Remember, we'll put that like towards the middle, is congruent to segment QR. We'll put that towards the middle, and these are overlapping triangles. They also want me to prove angle P congruent to angle Q. So what we'll end up doing is let's pull this guy apart like we did before. When you got overlapping triangles, here's this triangle right here that we want. And then the other triangle is in red, in this case. I'm going to pull those dudes apart. So I use the magic of editing to pull those apart. You can pause the video if you need to give yourself time. But here's my green triangle over here. Here's my red triangle. They told me that these guys are the same. They also told me that these angles are right angles. So angle PRS is a right angle. We got to put it in the real picture and in our pulled apart picture. And angle QSR, put it in the real picture, put it in our pulled apart picture. So nice. They want me to prove angle P congruent to angle Q, so what we'll do is we'll get the triangles congruent first and use a little CPCF. But how can I get these triangles congruent? Well, they have right angles in them. Boy, if I could get them to be right triangles, that would be cool for hypotenuse leg, but dude, I don't have like a hypotenuse leg situation going, so we'll check for a shared side, and isn't segment RS shared between each one of those? So we'll double tick in all places in the real picture and in our helper pictures. So I'm going to do that. Segment RS is congruent to itself by the reflexive property of congruence. And now I see a hypotenuse leg scenario. I just got to make sure I got all the right info. To do hypotenuse leg, I need right triangles. Nowhere in my proof does it say that I have right triangles, but it does say that I have right angles, so that's like the one step back that I need. They gave that to me, so dude, that's pretty nice. I don't need all that other stuff. I can jump straight to saying triangle PRS. I got a name on myself this time, so, and triangle QSR are right triangles. And because they had right angles in them, that's the definition of a right triangle. And that allows me, since I have a right triangle written down in my proof, that I could use hypotenuse leg if I have all of that juicy info, which I do. So I can prove the two triangles congruent. Triangle PRS is congruent to triangle QSR by hypotenuse leg congruence theorem. And that will allow me to get what I want here, angle P congruent to angle Q. So that's nice. And those are corresponding parts of congruent figures, so they are congruent. So hypotenuse leg proofs takes a lot of work, but you have to think backwards. If you're ever going to do hypotenuse leg, you need a right triangle in your proof. If you don't have it, you have to work backwards to see if you have right angles in your proof. We had that this time. Before that, you need 90 degrees. I don't need to put that down because that's already known if they say it's a right angle. And sometimes before that, they give you perpendicular. So there's just one last dude, and I got another typo on it. Sorry. I'll let you change this typo. This segment ZW right here, please change him to segment XY. And then when you write your given down, realize that we're probably going to do hypotenuse leg, and they gave me perpendicular, so that's the clue that says, okay, we need a lot of work. So why don't you give this guy a pause and see if you can get this proof done. Alright, somewhere in there, since they gave you perpendicular, you got to say that those angles, after you marked them with your tick marks in your right angle boxes, measure angle X equals 90 and measure angle W equals 90 by definition perpendicular. If you did the reflexive property already, that's cool too. Like, it's got to be done. It just doesn't have to be done right away. I didn't do that right away here. Here, after you say they're 90 degrees, you need right angles. So we'll say that they are right angles. And then those right angles allow you to have right triangles. So you say this triangle and that triangle are right triangles by the definition. And then, since I haven't done that shared side yet, I'll need to do that. So there's where I snuck in the shared side. Like I said, if you put that up here, that's totally awesome. You know, it's got to be in there somewhere. And now I do have my hypotenuse leg situation going. So those two triangles are congruent by hypotenuse leg. So if you ever do hypotenuse leg in a proof, lots of info needed. Let us know if you have any questions. Have a good one, guys.